This is another series in calculus, and in this tutorial I'm going to be talking about the strategy for finding limits. We have a lot of strategies in finding limits, so I'll be starting with a technique called dividing out techniques. Dividing out techniques. Yes. So I will show you how to use this method to find limit. Take for example, if you have something like this. Let's see our first example. If we ask to evaluate this limit x tends to 1, x cubed minus 1 divided by x minus 1. Now let's put our x is tending to 1. I shouldn't be talking about the other videos again because I know you already have the full understanding of how to find limits. So what we'll be doing here, we'll be plugging in 1 into our function. We'll replace x with 1. So let's replace our x with 1 here. We have 1 cubed minus 1 divided by 1 minus 1. So this one will yield, the answer will be 0 divided by 0, which is equal to 0. So we can't leave it like this. So this is when dividing out techniques will come in. We can't leave our answer to be 0. So if you are trying to find a limit and your answer is like you are getting 0 divided by 0, that means you have to use this technique to solve or evaluate the limit. So how do we solve this? Let me rewrite the function. We have limit x tends to 1, x cubed minus 1 divided by x minus 1. The first thing you have to do here, you have to check first. You have to check if your answer will be 0 divided by 0. If it is 0 divided by 0, then you have to use the technique that's which is dividing out technique. So we find out that our answer here is equal to 0 divided by 0, which is 0. So we cannot leave our answer like this. What we have to do is we will expand this function. Just look at the limit and check your function and see where there is power. In this case, we have power in the numerator, not in the denominator. So we have it here. What you have to do is just expand this. So which will be equal to x minus 1 x squared plus x plus 1 divided by x minus 1. This x minus 1 here. So this is what you have to do. You have to expand it. So we've expanded this our function here now. So let's now check if this one will still be equal to this one that we just expanded. Let's write our function here down. X minus 1 x squared plus x plus 1. Now let's check if our answer will still be x cubed minus 1. Now x multiplied by x squared will give us x cubed x positive x times positive x, that's x squared, plus x squared. Then x times 1 will give us x. Then minus 1 times x squared. We have x cubed plus x squared plus x. I'm writing this was x. So minus 1 times x squared is minus x squared. Minus 1 times x is minus x. Minus 1 times plus 1, that one is 0. That one is 0. So we don't have to write that one. So in this case, we have plus x squared minus x squared. They will cancel. Oh, sorry. Minus 1 times plus 1 will give us negative 1. Sorry. Will give us negative 1. So this and this will cancel. And positive x and negative x will also cancel. So our final answer will be x cubed minus 1. As you can see, we still arrive at our function here. So that means this is the expansion of this function here. We've expanded this function here. So we can proceed with our solution. So we can use this. Let me write it here. We have limit x tends to 1, x minus 1, x squared plus x plus 1 divided by x minus 1. So this is what we have. So I just check with this. We don't need this. Just check to know if this is the expansion of our function. Yeah. So we have this. X minus 1 will cancel with this. We now have limit x tends to 1. Tends to 1, x squared plus x plus 1. So this is what we have left. So now we can now plug in our function. We have x tending to 1 here. So we can now plug in 1 into our function. So we have limit. After plugging our 1 into this function, we have 1 squared plus 1 plus 1. So our final answer will be equal to 3. So that's our first example. So what did we do here? We are given this function. We asked to evaluate this function here, this limit here, this limit here. So the first thing you have to do is to plug in what x is tending to. You plug in 1. We have 1 cubed minus 1 divided by 1 minus 1. And we see that our answer is 0 divided by 0. That one is called indeterminate form. This form is not we can't leave this our answer. This thing here is called indeterminate form. So our answer is 0. So we cannot just leave it like this and just say that's our answer. That one is totally wrong. If you plug in what x is tending to and you see that your answer is 0 divided by 0, then know that you still have another thing. You have to expand the function that is given to you. So I check this and I find out that my answer is 0 divided by 0. So that one is indeterminate. That's the reason why I expanded this. Just look for the power. Our power is here. As you can see, x is not raised. We don't have any power for this x in the denominator here. So that's why I use this here, because we have power here. So I expanded it. I check here if this expansion is correct, and I noticed that I found out that it is correct. And I put this thing that we just expanded, I put it here, and I put this our denominator there, which is x minus 1. Then this and this cancelled. Then we have this left. Then I plug in what x is tending to. So I got 3. So that's our first example. Then the second example, second example I have here with me is example 2. Yeah. So the second example I have here with me is limit when x is tending to -3, x squared plus x minus 6 divided by x plus 3. So you just have to follow the same step here. This is 6. The first thing you have to do is to plug in what x is tending to, which is -3 in this case. So let's plug in -3 here. Just have to check. Let me write check. Yeah, check. So we put -3 here. We have -3 squared plus -3 minus 6 divided by -3 plus 3. So x is tending to -3. So I replace x here with -3. We have -3 here, -3 squared, square is here, plus -3, this x here, -3, then -6. Then we put this -3, we replace it with x, -3 plus 3. So we have -3 squared is 9. That's 9 minus 3 minus 6 divided by 0. So this is what we have here. So 9 minus 3 is 6 minus 6 divided by 0. So we still find out that our answer is 0 divided by 0. So this is still a indeterminate form. So our answer will be 0. So we can't leave our answer to be this. We still have to follow the same method. We still have to repeat the same method I did in the previous example, because this is indeterminate form. So let's continue. I told you in the previous example that you have to check where x has power. In this denominator, x is not having power, but here x is having power. So we have to expand the numerator once again. So if we expand the numerator, we have limit x tends to -3, x plus 3, x minus 2 divided by x plus 3. So this is what we will have. Now let's check again if this thing is actually the expansion of this here. Let's check. Let's recheck it again. We have this function here, x plus 3, x minus 2. Now x multiplied by x, that's x squared, let me move down here. X times x is x squared, is x squared, then x multiplied by -2 is minus 2x, yes, minus 2x, then positive 3 multiplied by x is plus 3x, and positive 3 multiplied by -2 is minus 6. So this is what we have. Now let's proceed. We have x squared minus 2x plus 3x minus 6. This one will now be x squared minus 2x plus 3x. That will be plus x. then minus 6. As you can see, we still obtain the same answer here. So this one, so here we should now know that our function here, this is the expansion of our function here. So we can proceed with our solution. So that means we can use this this function here. Let's now proceed. So I also checked here. Yeah. Let's proceed. We have limit x tends to minus 3, x plus 3, x minus 2 divided by x plus 3. So again, x plus 3 and x plus 3 will cancel. We only have x minus 2. We have limit x tends to minus 3, x minus 2. So we can now plug in what x is tending to here. So if we plug it in, we have minus 3 minus 2, which will be minus 5. So that's all about this video. What have I done so far? In the first example, the first thing you have to do is, in this example, we asked to evaluate this limit here. We asked to evaluate this limit. The first thing you have to do is to plug in what x is tending to. In this case, x is tending to 1. So I replace my x with 1 here, 1 cubed minus 1 divided by 1 minus 1. I found out that the answer is not, is an indeterminate answer. So it's in indeterminate form. So we can't leave it like this. We can't say that, okay, that's all for this solution. I just have to leave it by writing 0. No, that is totally wrong. So the next step is to, after checking, the next step is to expand our function. Check the denominator and the numerator and see where x has power. So that is what you have to expand. So I expanded it here. After expanding it here, I check again if this expansion is correct with this function. So I found out that it is correct. Then I proceed. I use it. I continue using the what I just expanded. I put it here. Then x minus 1 and x minus 1 cancelled. Then I have this left. So I plug in my 1 and I found out that my answer was 3. That's the first example. And the second one, same thing, just have to do the same thing here. I plug in my minus 3 and I notice that my answer is in indeterminate form. So I checked, I found out that is not, we can't determine it, is an indeterminate form. And I expanded it once again. I checked where x has power. It has it in the numerator. So I expanded the numerator and I got this. I checked if my function is if my expansion is correct by checking the function and also the expansion, and I noticed that it is correct. So I move on. I use the expansion. This and this cancelled. I have x minus 2 left. I plug in my minus 3 and I found out that my answer is negative 5. So thank you guys for watching. In the next video I will be solving 2 more examples regarding this topic, which is dividing out technique. We still have so many other techniques, but I just have to solve a lot of examples so that you guys will understand what I mean. So thank you guys for watching.